metals are reacted with water. So let us see that. And metals basically react with water, form metal oxide and what? Hydrogen gas. Metals react with water, gives metal oxide and release hydrogen gas. And further, these metal oxides, again metal oxide react with water and gives metal hydroxide and release hydrogen gas. Okay, so generally you have noticed that when you metal added to the water, it releases hydrogen gas and forming their respective metal hydroxide. But all of a sudden it will not happen like that. The step will take in two different manner. So first step is metals react with water and gives metal oxide and releases hydrogen gas, and these metal oxides again react with water and give metal hydroxide. Okay, for example, when you say take potassium, potassium react with water. Potassium react with water and it will give potassium oxide and release hydrogen gas immediately. Okay, so after releasing hydrogen gas, this potassium oxide again react with excess of water present in that one and it will give potassium hydroxide. Okay, so when you notice this reaction, there are two different types of steps will take place. First, oxide formation, then hydroxide formation. And these hydroxides are basic in nature. These hydroxides are basic in nature. Even metal oxides also basic in nature. Metal hydroxide also basic in nature. When you talk about the nature of this metal oxide and metal hydroxide, basically oxides or hydroxides. Okay, when oxides and hydroxide when you're taking, when they dissolve in water, the metal oxides or metal hydroxide which dissolve in water, they are called them as alkali. Alkali. So, who are alkalis? Alkalis are metal oxides and metal hydroxide which are soluble in water. Those metal oxides and metal hydroxide are called as alkalis. And if it is not soluble, if it is insoluble in water, those are called them as bases. Okay, now let us see how these metals react with water, and we can check the reactivity of metals based upon the reactivity series. Now I am writing reactivity series based upon the decreasing order: potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold. Okay, as per the 10th class CBSE, this much is enough. Okay, so in this, basically potassium react with cold water, and sodium also react with cold water. Calcium also react with cold water, and magnesium react with hot water. Magnesium react with hot water. From aluminium to iron, they react with steam. And after iron, from lead, copper, mercury, silver, gold. Lead, copper, mercury, silver, gold. These metals are less reactive elements which do not react with water. Which do not react with it may be a cold water, hot water, or steam. Okay, so after iron, these elements they do not react with water. Now the question is why potassium, sodium, and calcium they react with cold water. Okay, so basically these elements are highly reactive elements because of their more reactivity. Okay, so when you expose potassium and sodium, especially these two are vigorously react with atmospheric air and form potassium oxides. Okay, and sodium oxides. So these are highly reactive elements. So it needed cold water. Even calcium also highly reactive. It needed cold water. Okay, it doesn't mean that it will not react with hot water or steam. Even they reacting with cold water, even though they react with hot water and steam also. Here you have to notice that when they reactive with cold water, Okay, when they are reacting with cold water, here it releases energy. It releases large amount of energy. Large amount of energy. So you can see that large amount of energy in the form of heat. Okay, so you can see that these reactions are exothermic reaction which releases large amount of excess amount of heat. Okay, so how much heat means it causes even explosion. It causes even explosion. Even the small amount of potassium and sodium added to the water, it causes explosion. So we are using cold water. With cold water only it causes explosion. Imagine with hot water and steam how vigorously they react. Okay, so end of this video there are some experimental videos I have attached. You can notice the sodium potassium reactivity along with calcium. Okay, now calcium. So what is specialty of calcium here? So calcium react with cold water and releases hydrogen gas and calcium hydroxide. Okay, and calcium is a metal which float on surface of water. Along with calcium, calcium and magnesium, these two metals which float on surface of water. How it float on surface of water means when in a beaker just take water and add calcium metal. This experiment I already have added, you can watch. So when you added this calcium metal, calcium react with water, it form calcium hydroxide and releases large amount of hydrogen gas. Okay, so these gas attaches to the surface of calcium metal. When it is attaches to surface of a calcium metal, okay, so because of the formation of hydrogen bubbles, the calcium metal float on the surface of the water. And when you come to the aluminum and zinc and iron, these metals they react with the steam, they form metal oxide. They'll form metal oxide. See in above potassium, sodium, calcium, magnesium, you have noticed the formation of metal hydroxides. Okay, first four it will form metal hydroxide. Okay, next three it will form metal oxide. That you have to remember. Here it will form metal hydroxide along with hydrogen gas, whereas here aluminum, zinc, iron they form metal oxide along with hydrogen gas. Okay, so these differences you have to find definitely. um, Questions are repeated in this reactivity series. Now let us see how each and every metal react with water and their chemical formulas. Here potassium react with water. So which water it is reacted? It react with cold water and form potassium hydroxide and releases hydrogen gas. Okay, so we need to balance this equation. How will you balance? So here the hydrogen atoms are different. Okay, a number of oxygen atoms also, uh, oxygen atoms are okay, but hydrogen atoms are 3. So to balance this reactivity series, what we need to see, first of all you have to balance number of hydrogen atoms. So here I'll keep it 2 atoms, then it will become 4 hydrogen atoms. Okay, so make it 4 hydrogen atoms, and here 2 oxygen atoms are there, here 2 I'll keep, so 2 oxygen atoms. Now potassiums are 2 potassium. Now reaction is balanced. Even sodium also similar manner. Sodium also react with water, forms sodium hydroxide and releases hydrogen gas. This sodium again balancing the similar manner. So balance number of hydrogen atoms, make it 2 here. So 4 hydrogen atoms means here also 4, and 2 oxygen atoms means here 2. 2 sodium atoms are there, make it 2. Calcium atom, calcium react with water. Which water? Cold water. Okay, so here also cold water and here also cold water. It will form calcium hydroxide and releases hydrogen gas. Okay, it can hydrogen gas. So here how to balance this? Here 2 hydrogen atoms are there and here 2 hydrogen atoms. There are totally 4. So 2 hydrogen atoms and 2 oxygen atom balance. Now magnesium react with water. Which water? Hot water, and gives magnesium hydroxide and release hydrogen gas. Okay, similarly okay, so these 4 metals, when you see these 4 metals, what they are forming product? Hydroxide, their respective hydroxides and releases hydrogen gas. Here what we have noticed, so calcium and magnesium float on surface of water due to release of hydrogen gas. So among these two metals, which metal releases more amount of hydrogen gas? Calcium releases more amount of hydrogen gas. Now the question is, what about sodium and potassium? Even sodium and potassium also float on surface of water, but due to their vigorous reactivity, it catches fire here. Okay, they are highly exothermic reaction. But when you compare with sodium and potassium, calcium and magnesium are less reactive. Okay, and it releases more amount of hydrogen gas. Because of the hydrogen gas, these hydrogen bubbles attaches to the surface of this metal, which is responsible for float of this metal on the surface of the water. And when you come to the magnesium hydroxide is also called as milk of magnesia. Milk of magnesia. This milk of magnesia is used as antacid. Which used as antacid. Antacid means which reduces acidity in the stomach. Okay, so it is useful for gastritis, means those who are facing the gastric problem, to reduce the acidity. Milk of magnesia is using. Formula is magnesium hydroxide. So students, you have to remember that only four metals they form hydroxides. Now next three metals they will give metal oxides. Now we are reacting aluminum react with water. So which water? It react with steam. Aluminum react with steam and it form aluminum oxide and releases hydrogen gas. Okay. So now let us balance the number of oxygen atoms so that we can balance the chemical reactions here. So number of oxygen atoms are 3. So we balance 3 oxygen atoms. A number of hydrogen atoms are 6 are here. 3 2s are 6, means here make it balance. Now here 2 aluminum atoms are there, so make it 2. Reaction was balanced. Okay, and this metal oxide is also called as amphoteric oxide. Amphoteric means it react with, it act as, okay, instead of reactive you can say it act as acidic also, and it act as basic, means these metal oxides shows acidic behavior also and basic behavior also. So we call them as a amphoteric oxide. Okay, so next, zinc. Zinc react with water. This zinc react with water, form zinc oxide and release hydrogen gas. Okay, so here reaction was balanced. Now let us see, this zinc oxide also act as a amphoteric oxide. And next, iron react with water. Which water here? Steam. Water in the form of steam. Give Fe3O4 and releases hydrogen gas. Okay, so let us balance oxygen atoms. Here 4 oxygen atoms are there, make it 4. 2 4s are 8, so make it 4 here, and 3 iron atoms are there, 3. Reaction was balanced. So all these three metal oxides are amphoteric in nature, means which shows acidic nature also, basic nature also. So that means when amphoteric oxide react with acid, okay, it forms salt and water. Okay, or amphoteric oxide react with base, there also it react gives salt and water, like a neutralization reaction. Now after this, in the reactivity series, further few metals are there. So what are those few metals? Will they react with cold water, hot water, or steam? Let us see. So next is lead is there, next copper is there, mercury is there, silver, gold. These metals, they do not react with cold water, hot water, or steam. Why they do not react to? Because of their less reactivity in nature, they do not react with any form of this water. Okay, so this is about how the metals are reacted with water. and you need to remember that which metal react with which type of water, whether cold water, hot water, or steam. And even you need to learn the balancing of the equations. Okay, after ending of this video, I'm attaching sodium reactivity, sodium react with metal, one video. You can watch that experiment. Even calcium and magnesium, how it react with water and how it float on surface of water. You just notice, you will get more information. Okay, thank you.
But drop calcium metal into water. You can see it bubbles. It bubbles kind of rapidly. So you can see your first chemical reaction of the year there, too. The one currently? Previous one was magnesium. This one is the calcium. Little puffs of gas being given off. What you're seeing is the water vapor. You're not actually seeing the gas that's being given off. The gas that's being given off is hydrogen gas, turns out. So how reactive they are with water is one way to test their reactivity, and that's actually what we're doing today. We're going to react each of these with water. The next three are so reactive that they have to be stored with water, that they can't be exposed to the air, and so they're stored underneath oil. And so it'll take me a little longer to get them out and ready to go. It looks like the reaction is mostly finished. I see a little bit of bubbling still going on right here. And I see a bubble that's not popped there, but that means there's a little bit of calcium down here underneath this. Yes? Oh, I thought there was a question.
In this experiment, calcium and magnesium metal added to the water, and both metals immediately start releases bubbles. These bubbles are due to release of hydrogen gas. Which metal releases more amount of bubbles? You can notice here the calcium releases more amount of bubbles. Okay, and it start floating on the water due to release of more amount of hydrogen gas. After calcium, even magnesium also release hydrogen gas and it float on surface of water, and it is highly reactive that it releases fumes and it causes exothermic reaction. Okay, and you can notice here, so what is the reason to float calcium metal on surface of water? Due to release of hydrogen bubbles. These hydrogen bubbles attaches to the surface of the metal and the metal start floating on water.